Hi, Algebra 1. In this video, we're going to be going over how to determine whether a table is representing a linear function or an exponential function. And then we're going to practice writing an equation based on the table. So I'm going to start with table number 1 all the way on the left. I see that I always need to start by looking at my y values to figure out if I have a pattern that's multiplying by a constant, dividing by a constant, or adding or subtracting by a constant. So a linear pattern is always when we see that the y values are adding or subtracting by a number, and an exponential function is when we see that the y values are multiplying or dividing. Wow, bless me. Multiplying or dividing by a number. So if I look at my y values here, they're going 3, 6, 12, 24. Now, some of you might look at that and already be able to tell the pattern, but you can always test out adding and subtracting first, and then if you don't see a constant pattern, then you switch and try multiplying. So let's say I'm looking at this 3, 6, 12, 24, and I'm not really sure if I can tell it's going up, it's increasing, so it's either adding or multiplying. Well, let's test out and see if it could be adding. So for example, to go from 3 to 6, I would have to add 3. Now I need to see if I have to keep adding 3, if that will work as a consistent pattern or if it's something different. So to go from 6 to 12, I would have to add 6. So I can already tell that adding cannot be the pattern because it's adding by 3 between the first two numbers and adding by 6 between the next two. So that means it's not a pattern. So it can't be linear. It's not adding. It's obviously not subtracting because then the numbers will be getting smaller. Now we can try multiplying to see if it's exponential. So to go from 3 to 6, what would I have to multiply by to get from 3 to 6? Well, I would have to multiply by 2. 3 times 2 gives me 6. Now let's make sure that works for the rest. 6 times 2 also gives me 12. Good. 12 times 2 also gives me 24. So that means multiplying by 2 is the pattern in the table. So you can always check, once you see that it's increasing, test out adding. If adding does not work, then try out the multiplying. So we know this table is exponential because it's multiplying by the constant of 2. Constant 2. So it's multiplying by 2 every time between each y value. Now I need to use the table to write an equation. So since I know the pattern is exponential, I'm going to be using my equation. I have it written up here in the top left, y equals a times b to the power of x. So I just need to plug in the correct value for a and b. A is always going to be my starting value. And by my starting value, I mean it is the y value wherever the wherever the y-intercept is. Okay, so the y-intercept is wherever x is 0. So to find a, I always need to look at my table. Now it might not always be the first row. I have to find the row where I see that x is 0. So I'm looking on the left side of my table to find where x is 0. I see that's right here, that x is 0 at the top. It does happen to be the top row this time, but it might not always be. And then I need to look over and see what is the y value or the starting value when x is 0, and I see that it's 3. So that means that when I'm writing my equation, y equals, I always write y equals first, my starting value is 3. So my value of a is 3. Now I need to figure out my value for b. B is the growth factor, okay? The growth factor is exactly that number we were just looking at to see what number it's multiplying by. The growth factor is whatever number it's multiplying by. So in this case, that's going to be 2 because we already figured out it's multiplying by 2 each time. And then we need to remember always to raise that number to the power of x. So I'll say that one more time. We got the 3. The 3 is the starting value. So the y value when x is 0, also known as the y-intercept. So that number in the table, we go to where x is 0. We see the y value is 3. So our a must be 3. And then b is always the growth factor or the number that it's multiplying by each time, which in this case is 2. We had already figured that out. So our equation is y equals 3 times 2 to the power of x. Let's look over at table number 2. So again, I always start by looking at my y values to try and figure out what the pattern is. Is it adding, subtracting, multiplying, or dividing? So my y values are 16, 13, 10, 7. The first thing I notice is that this time they are decreasing. Okay, so that means I'm going to see, is it subtracting by a number or is it dividing by a number? So let's try out subtracting. You might be able to tell already by looking at it, but I'm going to just try and see if it's subtracting by a constant first. So to get from 16 to 13, what would I have to subtract by? I'd have to subtract by 3. To get from 13 to 10, I would also have to subtract by 3. And to get from 10 to 7, once again, I would have to subtract by 3. So it looks like subtracting is our pattern. If it's addition or subtraction, that means that it is a linear function. So it's linear. And we know that because it's subtracting by a constant 3. So it's subtracting by 3 every time, so it must be linear. Now to write our linear equation, we have the format y equals mx plus b. We're going to start by figuring out what m is. M is exactly what we just found. It's the constant that's being added or subtracted. Now, the one thing you need to remember is that if it's subtraction, you need to make sure your m is negative. So when we write this, we always write y equals, we are going to put negative 3 for m because it's subtracting. When it's adding, your m will be positive. When it's subtracting, it should be negative to show that. So negative 3 is our m. We copy down the x. That's always goes with the m. Okay, that's not an exponent, right? Because it's linear. Okay, it's multiplying with the x. Negative 3 times x plus, then we need to put our b value. And b is very similar to what a represents in the exponential function. It's the same idea for b in the linear function. B is whatever our sort of starting value is when x is 0. So again, we're looking for the y-intercept. So I always look over at the left side of my table, find where x is 0, and then find what is the y value when x is 0, and I see that it's 13, so my b value is 13. So I know it's kind of confusing because for exponential, b is the growth factor. For linear, the b is that starting value, which is what a is in the exponential function. Okay, table number 3. So again, always start by looking at the y values. We have 0, 2.5, 5, 7.5. First thing I notice is the numbers are getting bigger. So it's either adding or multiplying to get bigger. Okay. So usually I start by testing out the addition or the subtraction. So I'm going to see if it's adding by a number, a constant number. So to get from 0 to 2.5, I'm thinking, what would I have to add? Well, to get from 0 to 2.5, I would just have to add 2.5 exactly. 0 plus 2.5, I should put a plus sign. Plus 2.5 would give me 2.5. Now let's see if that works for the next one. If I add 2.5 to 2.5, what will that give me? It will give me 5. You can always check it in a calculator if you're not sure. Once again, 5 plus 2.5, that would give me 7.5. Again, check it in a calculator if you're not sure. So I do see that my pattern here is addition. So addition, again, means that it is a linear pattern. And we know that because it's adding by a constant 2.5. Now we're going to use that same format, y equals mx plus b, for our equation. So remember, just like last time, we write the y equals. We start with m. M is whatever we're adding or subtracting by. Since it's adding this time, our m should be positive. So we're going to put 2.5 because that's what we're adding by each time. And then multiplying by x always. And then plus our b value. Remember how we found our b value is we have to find 0 on the left side where x is and see what is that starting value. So here's 0. It's not always, as you can see, I mentioned at the beginning, it's not always the top row. You got to find where x is 0. Look on the left side. It could be any row. And then see what is the y value, what is the starting value when x is 0, and it's 5. So our equation is y equals 2.5x plus 5. All right, now into our last table. Again, I always start by looking at the y values. My y values are 20, 10, 5, 2.5. Now, the first thing I notice is that my y values are getting smaller each time, so it's either going to be subtraction or division. So let's test out subtraction. I always test out addition or subtraction first because it's usually easier to see. So I'm thinking, what would I subtract 20 by to get 10? I would have to subtract 10 from 20 to get 10. What would I have to subtract from 10 to get 5? I would have to subtract 5 to get 5. 10 minus 5 would give me 5. So I see that this is not working because I need to be subtracting by the same number each time. So my pattern must not be subtraction. That means I need to try division. Okay, so for division, I'm thinking 20 divided by what would give me 10? Well, that would be divided by 2, like dividing it in half, right? Half of 20 is 10. 10 divided by 2, that does give me 5. Perfect. 5 divided by 2, that also gives me 2.5. Again, if you're like unsure when you're doing it, you can always check in a calculator, do 10 divided by 2, make sure it gives you 5. 5 divided by 2, make sure it gives you 2.5. Now, you might be a little confused because we always say, you know, linear is multiplying or dividing, and we're going to have to, well, actually, I'll explain this in 1 second. Let's write down what we know so far. What we know so far is it's dividing by 2 each time, which means it's exponential, because exponential is whenever we see that the y values are multiplying or dividing. How do we know? It's dividing by a constant 2. So that's what we know so far. Now we have to write our equation, which remember is the format y equals a times b to the x. So we always write our y equals a for the exponential equation. That's our starting value, which means we need to find where x is 0. Go over to the y. See that y is 10 there. So that means our a value is 10. Then we're going to have our parentheses to the power of x. And inside the parentheses, we need to put whatever our growth factor is. Now, this is very important. We should not be putting 2 in here. Look over to table number 1. We put a 2 in the parentheses because it was multiplying by 2 each time. This one is dividing by 2 each time. So we shouldn't be putting a 2 in there. It's dividing by 2, which actually means we're going to put 1 over 2 in the parentheses. So the 1 over 2 tells us that we're dividing by 2 as opposed to multiplying by 2. Okay, the other way you can think about it is dividing by 2 is actually the same as multiplying by 1/2. So it's kind of like earlier when I said 20, I take half of 20 to get 10. It's just that same idea. Taking half of 20 to get 10 is the same as multiplying by 1/2. So your explanation can still say it's dividing by a constant of 2, but you need to make sure when you write your equation that you put 1 divided by 2 to show that it is a division in our table, not multiplication, okay? All right, I hope this helps you do your homework. Let me know if you have any questions.